Welcome everyone to the latest installment of the EuCAPT video profile series. My name is Bradley Kavanagh, and it's a great pleasure to have with us Sera Markoff, who is a professor of theoretical high-energy astrophysics at the Anton Pannekoek Institute and GRAPPA at the University of Amsterdam. Hi, Sera. Thank you for joining.
Hi, Bradley. Thank you so much for the invitation.
No, it's a pleasure. So I could give you a longer introduction, but maybe it's best if I let you do that. So maybe if you want to start off telling us where you're from and how you became interested in science.
Okay, so I'm originally from the US, although I've realized recently that I've lived in Europe pretty much as long as I lived in the US, hit that point. I'm not from a particularly highly educated family. I think my parents I was in that transitional generation, so my parents had actually gotten bachelor's degrees, but like they were kind of rare in my family. And nobody studied science. So my family was definitely either creatives or generally like more like blue collar workers or white
Yeah.
collar, they worked normal jobs. And so I was not really exposed to science, but I was part of a generation that they started to experiment with having more science in elementary school. This was because of the Cold War, actually. It's kind of interesting, and it was quite successful because I clearly thought science was very interesting based on this exposure. And then I started reading a lot of science fiction and comic
Okay.
books, and that drove my interest even further. And so I think at some point I just thought it would be cool to try to be a scientist, but it wasn't really the plan. It sort of happened a little bit by accident.
Okay. Okay. You mean in what sense was it by accident?
So in the US, unlike a lot of other places, everyone in high school studies the same thing. We don't track ahead of time. And then you decide what you want to do a little bit later. You can go to university and study a lot of different things.
Yeah.
But I actually went to a high school that had a special media arts program, and I was going to be an artist, I thought. And I got into art school, but I also got into, regular universities. At the last minute, kind of the night before, I decided I will try to do science and probably fail and go back to art school. This is a true story.
Okay.
And I never ended up back in art school. So yeah,
Okay.
that's
Yeah.
kind of how it happened.
I was going to say, I guess this means that you didn't flunk out of of science.
No
Yeah.
one was more surprised than me.
Okay, okay. So I'm surprised that we started already with the Cold War as the the opening of the interview as the reason that you're interested in science. Okay, so uh, after after not flunking out, uh, can you maybe tell us more about your kind of path through academia and where you are now?
Yeah, so I did all my education in the US up through my PhD. And then I wasn't entirely sure. So I studied what you would call astroparticle physics. They didn't really have a name for it that was catchy at the time.
It's a
And
relatively new field in terms of
yeah,
coalescing into having a name.
and I got my PhD in 2000, so it was kind of just at the beginning. I mean, it was definitely a thing, but it didn't have that name. And sometimes even people said particle astrophysics, which I still say, a bit by accident. Yeah.
Yeah.
But I wasn't sure if I was kind of drawn into cosmology as well. So I was an undergrad at MIT. And while I was at MIT, I took some great classes in cosmology, and I quite enjoyed it. I mean, people there like Alan Guth and like Ed Bertschinger were my teachers, and I'd done quite well in those classes, and I thought it was really cool, but I didn't know if that's what I wanted. In the US, you have to kind of know what you want to study, because the schools are good maybe at one or a few different things. You have to
Mhm.
decide where to apply, and I was very confused between that and more like high energy physics or astrophysics and black
Yeah.
hole kind of things. So I ended up doing a year that got organized very quickly, a kind of a gap year, that basically Ed Bertschinger had helped me sort of advise about. And he said, "Hey, I work with this group of people called the Seven Samurai, and they do cosmology. And one of them, is in Jerusalem. And would you like to, maybe go work with him for a year and kind of get a feel?" And I always liked traveling and adventure, so I said yes. And I worked with this guy, Avishai Deckel, for like a year, but at the time they hadn't discovered the supernova yet. This was just before, this was the 93, 94 academic year.
Okay.
And it was basically all kind of large scale structure and a lot of 4chan code. And I don't know, no offense to Avishai, it was great, but it wasn't my thing. And so I decided after that that I thought maybe I wanted to go more towards the particle high energy side. And so that's
Okay.
what I did with my PhD afterwards. And so I went to University of Arizona, where they had a unique program that was called theoretical astrophysics. You could kind of build your own program between physics, astronomy, and like plasma physics, and find
Okay.
your own advisors. It was a very great program. And so I did that. And that was how I got more into this kind of field. And then I went to Germany for my first postdoc as a Humboldt Fellow at the Max Planck Institute for Radio Astronomy, but they had a theory group. And I was interested in, looking at cosmic ray production and jets. That was kind of the idea. It's not exactly what I did, but and then I went back to MIT as a National Science Foundation fellow. And then I looked for faculty jobs on both sides of the ocean, and ended up here in Amsterdam, where I've been for almost 18 years.
For 18 years. Okay.
Yeah.
It it sounds like kind of your education and then path through academia has been helped a lot by the flexibility of different programs. Like you were saying about, for example, in the US, not necessarily having to, you know, track and take a very specific path early on, and then being able to kind of design your own program a little bit later on. It seems like it's helped you a lot. It's something that really suited you.
I think that's definitely true, and I've thought about that a lot because in the US, I think there is the advantage that kids are not tracked and not forced to choose too young. It's one of the things that I dislike about, especially the Netherlands. It's a great country in many ways, but what I mean is, if you're trying to find people who don't fit a certain mold, in my case, I would never have made it through a system like that because, you had to have the right kind of parents, the right kind of training, the right kind of school, the right kind of, teachers who thought that you looked the right way to be in this field. There's a lot of biases that come in.
Yeah.
And I think that probably the fact that I'm here has to do with these flexible systems. But on the other hand, I would say that what I find better at the moment in Europe compared to the US is that now when you go to the higher level of science, I think interdisciplinary science is a little bit more supported by funding agencies in Europe and actually encouraged more than I get on the US side. So it's interesting.
That seems to almost to be a contradiction, right? That
Yeah.
you're kind of encouraged to explore a little when you're younger, perhaps in the US, but then in Europe, there's a lot of focus at the higher level on this kind of interdisciplinary science. Yeah.
Yeah, I mean, and I don't think it's necessary that they say no interdisciplinary, but I think in the US, things tend to be more like you're either this or this, and you profile yourself. Whereas in Europe, there tends to be a specific emphasis also from the funding agencies on interdisciplinary science, which I quite like.
Yeah, and this is something I think that astroparticle physics in particular suffers from, right? It can be very
Yeah.
tricky to put it in a very specific box.
Yeah,
Yeah.
exactly. And so it isn't that it's necessarily easy to, astroparticle physics does suffer from that a bit here, in terms of where does it fit with funding. But on the other hand, I do think it is generally welcomed across Europe as a kind of exciting and interesting field. That's, there's things like astrochemistry and astrobiology and everything else, that are quite growing. So.
Yeah. Okay, so I think you've given us some hints so far about what you work on. Do you want to give us a kind of big picture of what you work on, what you're interested in, maybe even what the big questions are that you would like to answer?
Sure. Well, I mean, you could generally say I think that I've been focusing the last years on accretion physics, and I've sort of been sucked into the black holes for most of my life. But I am interested in this and other objects, but especially compact objects, because I think that you just have a lot of interesting physics that gets driven by strong gravity. And it drives things more to the extreme, also in terms of energy, in terms of particle physics, and in terms of the impact on the environment. So these types of topics connect to a lot of different fields. And I, again, like to move around and think about different things. And so most of the time, you could say, in one way or the other, I'm thinking about how gravity is this power source for all sorts of phenomena, but specifically around black holes, it often goes into these outflows like jets and winds that do exciting things for particle physics, but also really have a big impact in like cosmology, for instance, and galaxy evolution,
Yeah.
but even on smaller scales. And so those are a lot of the aspects I work on. And I think most recently I've also been involved. I've always stayed a bit involved in the observational side. As somebody who's mostly a modeler, but I think you have to really understand the observations. And so I'm also deeply involved in various telescope programs. I was involved with LOFAR a bit at the beginning, but then mostly I've been involved in the Cherenkov Telescope Array project and the Event Horizon Telescope project.
Yeah. Well, I was going to ask perhaps what if you could tell us about an exciting moment, a particularly exciting moment in your academic career. But I mean, maybe the Event Horizon Telescope images must be up there.
Yeah, I mean, obviously, I have to say I'm one of those people who tends to be kind of excited about science all the time. So I'm generally always really excited about a new result. But that was probably the highlight, just because I was also part of the team that got to present the results for the
Yeah.
first time to the world at the NSF press event in 2019. And that was both the scariest hour of my life, because you're on live television and there was like no margin for error. We were trying to time this across the world, and so everything had to be like
Yeah.
perfect, which was like no stress.
This is not
I
like
think we
giving.
were all shaking with drinking glasses like beforehand.
Yeah.
But it was really thrilling to be able to represent the team and to be able to show that science. And you don't really get to do that more than once probably in life. So it was kind
Yeah.
of cool to be part of that. Yeah.
Yeah. And often you're kind of in the details, and with people who are working on the same sort of thing, and so being able to stand up and like present it to the rest of the world must have been pretty amazing.
Yeah, and I think also we had no idea the impact it would have, like, because I think as physicists, right, there are big results for us, but then we make press releases, and it doesn't generally tend to get picked up. I mean, you think about gravitational waves. Obviously, it's one of the most fundamental detections ever for our
Yeah.
field,
Yeah.
but it just didn't play on social media quite the same way that the fuzzy red ring did, and something about that, and the
Yes.
color scheme that we picked, and it just had this resonance, and we were really, I think, very shocked at the beginning of how much, yeah, attention it
Yeah.
got from the public, which was great, but also not what we expected.
Well, do you have any thoughts on where that pull came from? Why were people? Is it just because it's such a visual thing that and it's in some ways a little easier for people to grasp maybe than, for example, the gravitational wave observations?
I think that's definitely part of it. I mean, I think gravitational waves are really amazing, but probably for the average person on the street, they don't really have a sense of it. And so it was less something that they could really connect with. Whereas black holes, even if people don't really know what they are, they're almost a household word. I mean, they're used in the lexicon, we talk about in advertising. I mean, they're
Yeah.
everywhere, and they're in the media and TV. And so people have this sense of black holes being fascinating and kind of scary. And then the visual aspect, we talked a lot in the collaboration later about, it was kind of accidental that we used that sort of red, orange, yellow. I mean, that is a very common color scheme you use in radio astronomy. But there are other color schemes like that are purple and pink and green, and we
Hmm.
just as easily might have ended up using one of those, and I don't think it would have had the same effect.
No, maybe it
So
wouldn't have.
we got the
Yeah.
Eye of Sauron thing and like
I,
all sorts of stuff, and it played into a lot of memes that people.
I was just going to say it gives big Eye of Sauron energy, which
Yeah.
which it sounds like was not intentional, but really caught people's imagination.
Yeah, exactly. And so that was kind of unintentional marketing, I think.
Yeah.
Yeah.
So that was obviously a pretty big moment. What do you think are the next big moments that you're hoping to see in the next decade, maybe even on longer timescales than that?
Yeah. Well, I'm really excited about the Cherenkov telescope array obviously turning on, because we already are starting to realize now that there's just this a hidden population of high energy accelerating objects. I mean, we still don't fundamentally know where ultra high energy cosmic rays come from, where even the lower energy cosmic rays in our galaxy are from, for sure. We have lots of suspects. But it's very difficult because just the big error bar, the big error circles on these things to identify them.
Mm.
And with the neutrino science picking up at the moment, of course, it's extremely exciting to try to put all this together. And I think if we want to figure this out for gravitational wave events, what they're doing once the, merger happens, and if they're contributing to high energy particles as well. We know there are gamma rays for the one that we've seen so far. What about neutrinos? What about other things? These are problems we need to solve, right? So I think CTA is going to be pretty groundbreaking, especially for transients. I think a lot of people haven't quite grasped how sensitive CTA is. And in fact, mostly when we see things popping on the sky, we use something like Fermi. But for fast transients, like under an hour, CTA in about the same range of energies, because it does overlap with the upper end of
Hmm.
Fermi, it's going to be like 10 to the 4 times, more sensitive. It
Wow.
just gets big.
Yeah,
And
yeah.
so I think every field that has looked blindly at the sky and like seen, new stuff that's exciting, and I imagine we're going to have a lot of surprises there as well that will kind of correlate with maybe also gravitational wave events. And there's all these optical transient factories and radio, SKAs coming. So a lot of this will be coming online, and I think we're going to discover a lot of new things. So I'm excited about that for sure. And EHT is trying to move into a new direction where we're expanding the array. Like, I'm part of a project to build a new telescope dish in Namibia that
Right.
will expand the array, but we also want to use that dish to monitor a lot of these objects when it's not doing EHT science, when it's just operating on its own together with gamma ray facilities and multi-wavelength. And I think the potential to actually see transients with global VLBI in the millimeter regime, that's what we're building towards with the next generations of EHT, these new prototype projects, I
Yeah.
think are going to just be amazing. We'll co-observe, with CTA and be able to image what's happening and solve, I think, a lot of these problems. So those are the shorter term, I would say, decade or two. And then I think 50 years, you were asking,
Yeah, yeah. I think yeah, 50
X-ray
years.
interferometry.
Okay.
So there's prototypes just being discussed at the moment now, but to actually do the full-on basically EHT in space in the X-rays, we have the technology to do this. It's just a matter of, prototyping and testing. But I think this is doable within, hopefully, I don't know if I'll be alive, but if I live to a ripe old age.
But this would be to look at the same objects, so accreting black holes, but in X-rays rather
Or
than.
anything, anything you
Okay.
have want to have that resolution for. Yeah. I mean, the idea is that you can get microarc second resolution, but in the X-rays, and that
Wow.
is just a phenomenal idea, but it is feasible.
Okay.
So
Okay.
yeah.
Yeah. No, you talked about, for example, with Cherenkov telescope array, essentially looking at the sky and seeing what's there, and we're expecting some things, and some things for sure we're not expecting yet. And it's actually been a kind of common theme with some of the other people I've spoken to. This idea of, you have things that you're expecting and you're excited about, but there's also going to be things that you have no clue they're coming, and you just
Yeah.
have to open the box and see what's there.
I think we already have hints of this. The fact that the current generation of very high energy Cherenkov arrays, instruments and arrays like HASS, MAGIC, Veritas, they're seeing gamma ray bursts with crazy spectra that look like they should be maybe synchrotron. I mean, this is just, all this stuff is changing our view. And the LASSO sources as well, that we have all these pevitrons in our galaxy, but we're not really seeing the supernova. I think there's going to be some big paradigm shifts.
Okay. Okay. No, it sounds like an exciting decade ahead, and maybe even, if we
Yeah.
can get X-ray interferometry to work, that sounds incredible. Yeah. So maybe we can shift gears a little bit and talk about you as a scientist, as a person. Are there some things you like? Well, maybe you can tell us some things you like about being a scientist and some of the downsides.
Yeah.
It's
Well, I
tricky,
mean,
but
I think the parts that I like are, I like the freedom. I mean, I've never been the kind of person who likes a routine. I have worked normal jobs, in the US, if you don't come from money, you have to pay your way through school. You have to do, so I've done quite a lot of normal jobs where you sit staring at the clock every day and you work, this drudgery from 9 to 5. And I don't like that. I like to have every day be a bit different and have a little bit of flexible, kind of maybe chaotic schedule that suits me. So I really like being surrounded by people who are motivated by curiosity,
Mm.
and that's the great thing about being in science and working as a professor at a university. I work with a lot of young people, and that's also really fun to kind of keep things going. But what I don't like is maybe the fact that sometimes, your schedule does get out of your control. I mean, there's ups and downs, and it can be exhilarating but exhausting. And there are times where I think we all suffer from overwork because of that, because sometimes you just don't realize that certain things you agreed to a year ago are all going to like pile up. And I'm sure that time management's not my strong suit, but
This is a piece of advice that someone gave me once, which was before you accept an offer to talk or something in 6 months,
yeah,
you should think about how you would feel if the talk was next week, because you'll still be the exact same person with the exact same workload
it's
6 months from
exactly
now.
true. Yeah. And I think there's another thing that's specific to being, at least maybe it's age and seniority or something, but and maybe being at a university, but I find that the thing that brought me into science was being curious, being able, and I'm kind of nerdy and I like to code and get my hands dirty. But the older I get, the less time I have for that, because there's more responsibilities that end up being committees, and those are great responsibilities, and it's important to do them.
Mhm.
But I do kind of live a bit vicariously through my group sometimes. Like, I miss my students think I'm nuts because I'm excited about debugging and stuff, like,
Yeah,
but it's like a treasure hunt. You have to figure out what's going on.
it's fun, guys. It's fun.
Yeah,
So
exactly. But I mean, in a weird way, that I do really like that aspect. And so I
yeah,
do miss getting my hands dirty in the way that I used to be able to just have hours of time to just uninterruptedly work and think.
yeah.
Yeah.
So when your schedule does kind of get on top of you, or when you feel like you've overworked, what sort of things do you do to unwind?
So anyone who knows me knows the answer to this. I'm a big music fan. So I go to a lot of live concerts when I can. I really like live music. I wouldn't say it's necessarily relaxing, but it energizes me. It's a way
Hmm.
to kind of like, I find it really a great balance to thinking all day. I like to go out, with my husband or my friends, and we do a lot of cultural things around town, cooking and eating and art. When I'm really exhausted, though, I have to admit, like, I'll just crash on the couch with my husband and my cat Bandita, and we watch bad sci-fi, like binge watch.
That sounds perfect. Yeah, so
Yeah,
you said art. I mean, you kind of come in some ways from a somewhat art background. You still
yeah.
keep in touch with that?
Um, yes, I mean, I'm not an actor. So I used to be a musician and I used to be an artist, both of which at some point I think I realized I'd probably be better off as a fan than doing this professionally, and but I miss it, and I do keep in touch. I mean, a lot of my friends from the old art and music days I'm still friends with, and I keep track of that. I like to go to museums. I like to read and see about art and literature. I mean, I definitely still have that creative side, and I think it mostly comes out if anyone sees my slides. I make really pretty slides. Like, that's where I get my art vibes out.
Okay, okay. No, it's nice. This is the
Yeah,
synergy coming
yeah.
coming back again, combining art and science.
Well, I think that I mean, I think a lot of scientists have that. As far as I can see, there's especially a strong connection with music,
Hmm.
in particular. But I know many, many scientists who not only are interested in music, but also art. So I think that there's just a lot of times people think science isn't a creative art, but it is. You have to be creative to be successful.
Yeah, yeah. Um, so maybe I can ask you now a little something about your views on EuCAPT. So EuCAPT was created essentially to bring together the European astroparticle theory community. Um, what do you see as EuCAPT's role, or what role can they play in that?
Yeah, I mean, these sorts of networks are really important. I mean, it's not just about connecting people for collaboration, which of course is important, but it's very important for things like advocacy. The situation in Europe is really complicated in comparison to where I'm from, like in the US. I mean, we have this sort of federation of states, but the science funding and the policy is really being determined at a national level. So you have this single country that's basically the size of Europe, but it makes it much easier to coordinate the
Yeah.
um, And in Europe, you have, these different levels because you have strong science policy and funding coordination, both nationally, but then also increasingly now at this EU level, and they don't always talk or agree. And I think that makes it hard to kind of keep track of what each other are doing and try to work together and prioritize. So it's especially important for us to band together and really think as a group, what do we need to advocate for? What do we need? How can we work better as a team to achieve our goals? And especially for like large facilities where, we're talking more about theory maybe, but we need better computational facilities that we can all use. And I think this kind of coordination happens for experiments and observations, but a little bit less for theory,
Yeah.
cosmology, and astroparticle. And so it's really important that we have this strategy document, this white paper that we
Yeah.
all wrote together. It's very good because you can point to this to funding agencies or to government people and say, this is our strategy. You have to put it on paper.
This is what we're aiming for, and coming
Yeah,
together like this is a kind of way of achieving like a critical mass behind some of these ideas. Yeah.
yeah.
Yeah. So I think my final question is, what advice would you give either to your younger self or to younger colleagues who are only just starting in the field?
Yeah, it's always so hard, right? Because I mean, I think everybody's a bit different, but to me, like if I could think of maybe like a couple things, I think staying curious is really important. I feel like sometimes the new generation, maybe I sound really old, but but it starts to get so object oriented. Like people have this checklist and they think I'm going to do this, 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 and this, but then they lose the joy. And I understand that, building a career can be stressful, but you
Mhm.
have to kind of embrace the uncertainty and become comfortable with the uncomfortable,
Yeah.
because being uncomfortable is growth. Like, I mean, it never feels comfortable to be pushed into a new direction. And I think it's really important to, use that curiosity to kind of drive you to break out of your comfort zone and keep learning new things and try to like enjoy what you're doing because it's not, no one makes us do this job or they shouldn't, it can have, like any job, rough patches. And I think that what gets at least me through is this kind of curiosity and trying to understand and realizing like how cool it is that you get to study all this stuff that very few people really seem to notice in their daily lives but is very relevant for us, right? So
Yeah.
that's my main thing. And then I guess my other advice would just be be nice and take time to also give back. I think a lot of people look at my career and they say, oh wow, you've done all this stuff. They don't see that I also do a significant amount of volunteer teaching. I do a lot of community advocacy. Um, and I see young people focusing 100% often thinking that the only thing that's going to help their career is, just cranking out like one more paper.
Yeah.
But in fact, the juggle that we need to do and the way that we need to get funding, I mean, doing outreach really helps with that actually, because if you can explain what you're doing to like children, I mean, I think Einstein said that, then you really know what you're talking about, first of all, but also you can engage a politician as well, because
Yeah.
politicians need to be grabbed, or the person reading the 100th, you know, uh, application for some grant, so you have to learn how to like focus on the interesting things and appeal to people. And doing these extracurricular things is really important for your career. And it's also giving back to the community and that pays us, right? So I think
Yeah.
that's also important.
I think this also links back to the curiosity aspect because I think one of the things doing any kind of outreach activity, like sort of stepping out a little bit away from the kind of academic office space and speaking to people outside of that, it always reminds me how cool the stuff is that I'm working on, right? You, like I was saying, you sometimes get a little bit caught in the details,
Yeah.
and then you
Or
go out and
jaded.
you
Yeah.
yeah, and then you go and speak to kids or sort of have an interview or something, and you realize as you're describing it that it gives you just a little renewed reminder that it's something really incredible that
Yeah.
like you
No,
said, very
exactly.
few people get the chance to do.
Yeah, and I think when you see how excited people can be about this, and kids also saying like, "Oh, I want to grow up and do this kind of stuff." I mean, it can really energize you. So, I think that you shouldn't just be so unifocused. Yeah, that would be
Yeah.
my last piece of sage advice.
Okay. Okay, maybe that's a good point to stop then. So I'll say thank you very much to everyone listening, watching. Thanks very much, Sarah, for joining us. I think it was a
Yeah.
really, really interesting conversation.
Excellent.
Okay.
Okay.
Thank you very much, everyone.